A warm greetings to one and all. In this session, let's learn about virtual function, pure virtual function, and abstract class. Virtual function is a member function in the base class, which is redefined in the derived class. It is declared using the virtual keyword. It is used to inform the compiler to perform dynamic linkage, which is also called as late binding on the function. It is necessary to use single pointer to refer all the objects of different classes in virtual function. We create a pointer to base class that refers to all derived classes here. Virtual is a keyword preceding the normal declaration of the function in order to define or declare the virtual function. When the function is made virtual, C++ determines which function is to be invoked at the runtime based on the type of the object pointed by the base class pointer. Now let's see what is late binding or dynamic linkage. In late binding, function call is resolved during the runtime. So only during the runtime we can resolve the function call. Therefore, compiler determines the type of object at runtime and then it binds the function call. Now let's check out the rules for virtual function. Virtual function must be a members of some class inside the program. Virtual function cannot be static members. They can access through object pointers. They can be friend of another class. A virtual function must be defined in the base class even though it is not used. The prototype of virtual function of the base class and all the derived class must be identical. If two functions with same name but different prototype, then C++ consider them as overloaded function. We cannot have virtual constructor, but we can have virtual destructor. Now let's have an example program using function overriding in order to understand early binding. In this example program, we have defined the class definition for class A. Class A defines show function which executes the out statement and displays the message base class. Next, we have defined the class definition for class B, where class B colon public A states that class B inherits the properties of class A. Class B defines the show function, which executes the out statement and displays the message derived class to the user. Here we can notice that class A and class B declare the same function show. The function name is show, which is similar in class A and class B. The return type is void, which is similar in both class A and class B. And the argument type is also same, which means it has no arguments in class A and class B. Now let's see how program gets executed. The execution starts from main function. In main function, we have declared the object A1 for class A. We have declared the object B1 for class B. Using class A object A1, we have accessed the show function. Now control moves to class A, executes the show function and displays the message base class to the user as shown in the output. Next, B1.show. Using class B object B1, we have accessed the show function. Now control moves to class B, executes the show function and displays the message derived class to the user as shown in the output. Next, again we have B1.show. The intention for this statement is to access the base class member function show. But here, since the prototype of show function which is available in class A and class B are similar, class B overrides the class A show function. Instead of accessing class A show function, this statement accesses the show function which is available in class B. So it executes the show function and displays the message derived class as shown in the output to the user. Normally, in inheritance, using derived class object, we can access the variables and member function which is available in both base class and derived class. But here, we are unable to access the base class function using derived class object, since class B overrides the class A. This concept is called as function overriding. Here comes the violation in inheritance properties because class A and class B has same function with similar prototype. And also due to early binding concept, that is the process of object declaration, function declaration, and function call is determined during the compilation time itself. This process is called as early binding. So using this example, hope you all are clear in function overriding and early binding. In previous example, we have noticed that function overriding violates the inheritance property. which has happened due to early binding also. So to avoid it, in this example, we have used virtual function and late binding concept. In this example, we have defined the class definition for class A. Class A defines show function, which is declared along with the keyword virtual, which executes the out statement and displays the message base class. Next, we have defined the class definition for class B. Class B colon public A states that class B inherits the properties of class A. Class B defines the show function, which executes the out statement and displays the message derived class. We can notice that class A and class B declares a function with same name, that is show, same return type, that is void, and same argument type, that is no arguments. Let's see how program gets executed. The execution always starts from main function. Here, A star P implies that for base class A, we have created the pointer variable P. Next, we have created the object A for class A. Next, P is equal to ampersand A. That is, here we have assigned the address of object A to the class A pointer variable P. Using arrow operator, the pointer variable P accesses the show function which is available in class A. Since we have assigned the address of object A to the pointer variable P, now the control moves to class A, executes the show function and displays the message base class to the user as shown in the output. Next, we have created the object B for class B. Next, P is equal to ampersand B. Here we have assigned the address of object B to the pointer variable P, which belongs to class A. Since we have assigned the address of object B to the pointer variable, now here using arrow operator, the pointer variable P accesses the show function which is available in class B. So now control moves to the class B and executes the show function and displays the message derived class to the user as shown in the output. So next it is return 0, which implies that the program executes successfully. In this example, we have declared the same function show with similar prototype in both base class and derived class. Since class A show function is defined as virtual, it can be overridden in derived classes also. That is, class B cannot hide class A function as we have noticed in function overriding concept. By using base class pointer variable here, that is star P, it is dynamically binded to appropriate implementation based on the object which we have referred during the runtime. So that is during runtime, we are deciding the function to be executed, which is called as late binding. Hope you are clear in virtual function and late binding. Disadvantages of virtual function. Virtual function incurs extra overhead due to dynamic dispatch. Virtual function increases code complexity and it is hard to understand. Due to dynamic in nature, it is difficult to fix the bugs. It results in high coupling of classes and reduces code modularity. Since it requires testing multiple classes and method combinations, testing becomes complex. Pure virtual function and abstract class. A function that has no definition is also called as do-nothing function. Do-nothing function is also known as pure virtual function. Pure virtual function does not have definition in it. That is, the base class does not have implementation part for the pure virtual function, but derived class must provide its own implementation part for the pure virtual function. A class containing the pure virtual function cannot be used to declare objects of its own. Such classes are known as abstract base class. The main objective of the base class is to provide the properties and characteristics to the derived class and to create the base pointer which is used for achieving the runtime polymorphism. Pure virtual function can be defined as virtual. Virtual is a keyword followed by return type, method name. It can have its own list of arguments followed by equal to 0 ended with semicolon. Example for pure virtual function and abstract class. In this example, we have defined the class definition for class A. In class A, function show is declared with keyword virtual and assigned with value 0. That is, the function is called as pure virtual function. For pure virtual function, we will have declaration part in base class always. It does not have definition part, that is implementation part in the base class, since the derived class should provide the definition for pure virtual function. If a class has at least one pure virtual function, then the class is called as abstract class. For abstract class, we cannot create the object since it has incomplete function definition inside it. Next, we have defined the class definition for class B, that is class B colon public A. So class B inherits the properties of class A. Class B defines the show function. It executes the cout statement and displays the message derived class to the user. Now let's see the execution of the program. The execution of the program starts from main function. A star P implies that for base class A, we have created the pointer variable P. Then we have created the object B for class B. Next, P is equal to ampersand B implies that we have assigned the address of object B to the pointer variable P. Next, using arrow operator, the pointer variable P accesses the show function which is implemented in class B. Since we have assigned the pointer variable with class B object. Now control moves to class B and executes the show function and displays the message derived class to the user as shown in the output. Next, return 0 implies that successful execution of the program to the user. The core advantage of pure virtual function is it allows to define the abstract class. Then it defines the common interface for derived classes and allows each derived classes to provide its own specification implementation. It also provides polymorphism and helps in code organization. Hope you are clear in this example for pure virtual function and abstract class. Thank you all.